This video will show you how to find a least common denominator. Let's go ahead and first start where the fraction problems do not have any exponents and variables. So if we're trying to find the least common denominator, remember whenever you add or you subtract fractions, you need the denominators to be the same. So you can see here we have a 6 and a 4, they're not the same. So we have to think of a number that they both go into and change the denominators to that number. Now, so for example, 24, right? 6 can go into 24 as well as 4 can go into 24. But this video is going to focus on how to pick the least common denominator, so LCD. So we want to see, is 24 the smallest, or is there actually a smaller number? Now, many of you probably know it's 12. So I'm going to show you a process that will work even if it has variables and exponents. So if I want to find the least common denominator of 6 and 4, you would need to take 6 and 4 and break it down into its prime factors. So think of two numbers that multiply to 6. So for example, 3 times 2. And then the only number that can multiply to 3, the only two numbers, is 3 and 1. So when that's the case, you're done. Same thing here, it's only 2 and 1, so it's prime. So we want to do that with any of the numbers. Okay, so then once they are completely factored, you're going to look and see what's in common. So I see a 2 here and I see a 2 here. So to find the common denominator, we need the 2. And then we need to include what's not in common. So a 3 and this 2. And when you multiply that all together, it's going to get us 12. So again, to recap, you take what they have in common and multiply it with what's not in common. So when we do that, we get that the least common denominator is indeed 12. So let's use that same process on this problem here on your homework. Now I do have a typo in the homework. It should say find the least common denominator. That's what we want to find. And I broke this into 3 steps. The first step is already going to be done for us. I have already factored all the problems for you so that you don't have to worry about that step. I want you to focus on step 2 and 3. So step 2 is to find out what's in common. So I see an x plus 5 here and an x plus 5 here. So we need x plus 5. So this is what's in common. Now let's talk about what's not in common. So here we have an x plus 5. And here we have an x plus 2. And this would be our common denominator. Let's try another example. So first thing again, I've already factored it for us. We need to highlight what's in common. So I see an x plus 2 here and an x plus 2 here. So we need x plus 2. And now we need what's not in common. The x minus 3 and the x plus 1. And that is the common denominator. Let's check out another one here. Here we have 28x squared y, and we have 14xy. So we need to think of the smallest number that 28 can go into and 14 can go into. So again, some of you may know, but if you don't know, we can always pick two numbers that multiply to 28, so like 7 times 4, and 7's prime, but 4 can be broken down to 2 times 2. And then here we have x times x, and we have y. Okay, over here we have 2 times 7, and those are both prime. And then we have x, and we have a y. So we're going to now find out what's in common. So I see a 7 and a 2. on both of them. And then I see an X and a Y. So that's what's in common. So we have, what's in common is we have the 7 and the 2, so that makes 14. And then we have an X and a Y, so that's what's in common. But we have to also include what's not in common. So for example, this 2 right here, this X right here, that's what's not in common. Now we're going to multiply that all together, simplify it up to get our least common denominator. So we have 14 times 2, that's 28. So do you see that 28, both of these numbers go into? So that's our least common denominator. And then we have an X here. And remember, when we multiply, we add the exponents. So we have X squared. And then we have Y. So this is our common denominator for this problem. Now, what you'll notice as we do more problems, if you look at the X's here, this one's X squared and this is X. And our answer is X squared. It's always the one with the higher exponent. Here we have an X, or a Y, I'm sorry, and here we have a Y. And notice we have a Y here because one of them's not bigger than the other, so therefore the highest is just the Y. Okay, here we need to find what's in common. So if we look at number 4, there is nothing in common. So now the last step is find what's not in common. So we have a 4, we have an X, we have an X minus 3, and we have an X plus 5. And that's our common denominator. Has nothing in common. So we needed all of that. Okay, so here we have to find out what's in common. So we have an X minus 4 and an X minus 4. And now we need to look at the 8x to the 4th and the 6x cubed. So some of you, again, may know what 8 goes into and 6 can go into, the smallest number. If you don't, we can break this into prime factors. Here we have 4 x's being multiplied, and here we have 3. So let's go ahead and find out what's in common. So we have a 2 and a 2 here. And then we have 3 x's here and 3 x's here. So 2x cubed is, so all of this they have in common. Now we need to include what's not in common. So this 2 and this 2 and this 3. So that would make 12. And then this x is not in common. So if we simplify this up, we'd have 2 times 12, so that's 24. And then we have x cubed here and another x there, that's x to the 4th, and then x minus 4. So this is our common denominator for this problem. Now remember what I had said about the highest exponent, so x to the 4th is higher than x cubed, and notice we have x to the 4th here. All right, let's take a look at this one. So underneath one of the fractions, we have x plus 3 cubed, and this is what x plus 3 cubed would look like. So we need to find out what is in common here. So I see an x plus 3 on the left here and an x plus 3 here. So we would have x plus 3. Now we need to include what's not in common, both of those. So x plus 3 times x plus 3. So this would be our common denominator, or you can also write it as x plus 3 to the second power. Oops, I should say that would be x plus 3 to the third power, because there's 3 of them. Okay, so let's try this problem here. So let's find what's in common. So x minus 1. And we have x plus 3, which is not in common. And then we have the monomials. So we have the 4x, and we have the 6x cubed. Now, the quick way to do it is what can 4 go into, and what can 6 go into? So I think we had this in a previous problem. It would be 12. And then the one with the higher exponent. So it'd be 12x cubed would be the least common denominator out of these two. Now, let's make it visual and see how to get 12x cubed by writing it out as prime factors here. Here we have an x, and here we have 3. So let's go ahead and search for what's in common. And they each have an x. And now what's not in common? This 2 and this 3, so that would make 6. And these two x's here. Okay, so we have what's not in common with what's in common. And if we simplify that all out and multiply it together, we would get 12x squared times x minus 1 times x plus 3. That is our common denominator. Oops, I just noticed I put x squared here. But actually, if you add the exponents, you have this one and 2. That should be cubed right there. So go ahead and make that change there. So this is our common denominator. In this problem, we just have monomials. So the fast way to do it is what can 8 go into, and here there's a 1. So 8 and 1 can go into 8. And then they both have x's. You take the higher exponent, so x to the 5th. They both have y's. You take the one with the higher exponent, and this would be our common denominator, our least common denominator. Now, if we go through and make it visual, we can break 8 into 2 times 4, and the 4 into 2 times 2. Now we broke it into its prime factors. We have x times x, and we have y to the 4th power. And then over here we have 5 x's and 3 y's being multiplied. So if we find out what's in common, we could see x times x, and in addition we have y to the 3rd power in common. Now, as for what's not in common, we have 2 times 2 times 2, so that's 8. And then we have this y here, and we have these 3 x's here. So, putting that together, our least common denominator would be 8 times 1, so 8. And then if we add the exponents, 2 plus 3 is 5, and 3 plus this one is 4. So that is our common denominator, least common denominator. Okay, so let's go ahead and start with what's in common. So I see an x here and an x here. So they both have an x in common. And then the 4 is not in common, and the x plus 5. So if we put that all together, our least common denominator is 4x times x plus 5. All right, last one here. So let's go ahead and start with what's in common. So I don't see that they both have an x minus 3, so we need that. I don't see that they both have an x minus 4, so we need that. I don't see that they both have an x minus 2. And I don't see they both have an x plus 5. Okay, now we have a 2 and a 6, so we have to think of what can 2 go into and what can 6 go into. What's the smallest number? So if you're thinking 12, true, but it's not the smallest. So if I want to verify I have the smallest, I'd break them into their prime factors. So the only thing that multiplies to 2 is just 2 and 1. And then 6 would be 2 times 3. So what they have in common is the 2. And then what they don't have in common is just the 3. And 3 times 1 is just 3. So if we put that all together, it would make our common denominator 2 times 3 is 6. And then we'd have times x plus 5 times x minus 2 times x minus 3 times x minus 4. So that would be our common denominator there.